and therefore it creates a calcium carbonate, and it would be precipitated inside the soil and creates a natural cementation. Many of the rocks that we have got under the ground, basically, which are strong, naturally have this calcium carbonate precipitated over millions of years. That's why they are strong, and here I can see there is a great potential there. So for the source of calcium that we need to add in there, so I guess to this urine, you can say, so there are a few positive things. So if we lose urea in a low pH, unfortunately we cannot use. So when we add the calcium hydroxide, so it elevates the pH. Therefore, as you can see in this graph, the loss of the urea would be minimum. So therefore, we can utilize it, and in the same time, it creates the source of binder to create the calcium carbonate. And this source at the moment, our idea is creating this one through the lime mixed with water, or in lab through the solution of calcium chloride and sodium hydroxide. So that's how it looks. So there will be a fair bit of mechanical testing in addition to chemical testing. So we're going to test the Bridgely shale and break it down to small particles. We're going to test it on loose sand as well, and expansive soil. So we're going to do comparison of this treated urine with urease, and then compare it with addition of the normal Portland cement, or general purpose cement we call it here in Australia, and lime stabilization, and see how good is this treatment compared to the other existing practices in the industry. And the test that we do, again, I understand most of you apparently are not civil engineers, but we will create samples and then crush them and measure the strength of it, but under different conditions that is required by standards for road construction. We will also do the leachate testing to make sure what is going there through the groundwater flow and so on doesn't create what is not, again, acceptable. Permeability and so on would be all considerations for road and railway construction as well. So some, again, ideas to address the challenges of the byproduct of ammonia that we have there is that, again, some of the research we have done shows that natural zeolite can be added to remove the ammonia. So again, I'd like to learn from the members of the hub more on this. So we can also use the PAA to immobilize ammonia. It's not removing it, but it just stays there in the soil. And also we're going to try the normal drying on site to see how it goes. Obviously that releases ammonia, so which is a problem, but we're going to look at it. And the proposal also there that we can work is that we cover the surface of the ground using membrane and control this ammonia. It might be used for hydrogen generation and so on. So remember, the scale of the work we are talking about here is we are talking about improving the ground for kilometers, or 30-40 kilometers of road. So the scale is significant. So, and obviously we have done just some basic calculations in there. Obviously there are a lot of benefits in terms of replacing the cement or general purpose cement and reducing the carbon footprint there we have got. And in some of the developing or underdeveloped countries that Australian companies are operating there, such as Pacific Island, they don't have a chance of having the cement even. So, but I'm sure they have a chance of having urine there. So therefore, seems it's possible even to help there. And of course, we need to improve the environmental image of construction industry and move towards sustainable buildings. So here, just as the kind of last sort of slide, I guess, I show we have got 5.3 million of population here in Sydney, assuming each person creates 1 liter of urine per day. We are generating 5.3 million liter per day here just in Sydney, and seems this is enough to stabilize the ground for 30 kilometers of road for 2 lane per day of production. Therefore, to somehow, also this is a competition, I guess here, you like to use it for fertilizer, but we have some use there as well. And this addresses quite a number of SDGs, including the industry, innovation, and infrastructure, reducing inequity, sustainable cities and communities, and so on. So, and partnership, some of them are common with fertilizer, obviously, and some opportunities for collaboration. I like everyone to think is that one is that we are using the enzyme urease. So if there are some other bacteria or techniques, I just had a chat with Stefan a bit earlier today, so might be some other ways to separate that carbonate and then mix it with calcium. So obviously minimizing generation of ammonia or controlling it, if there are techniques we can use, but please have it in mind that we are talking about kilometers of road. So, and we can use this technique for other cases such as tailings and concrete break and so on. And the other interesting things that I didn't get a chance to talk to Sean last night putting this together, I thought is really adding this material or product that we are thinking to the soil to increase the water retention of the soil, which is good for the drought and applications in the agricultural field. On that note, thank you, and I appreciate my CI, Professor Kapos, who is also here, and thank you on that.
Thank you, Reza. Thank you.
Thanks, Reza. And I know we already talked, but I just had another thought. The Yugo process basically takes the urea, converts it into ammonia and carbonate. Then we get the ammonia out because we want to recover the nutrient. And we have a byproduct which is rich in carbonate, pH close to 10. Could that work? Because you really don't want the ammonia in your system. So it might be better just to work with what you discard already, because all you want is the carbonate.
Absolutely.
What's the ideal pH for the soil to stabilize with this cement?
I think pH of around 8, 9, 10 seems good to me, actually.
So maybe
I think this is fantastic opportunity. If we can make use of what you're not using even, yes, great. Let's talk more.
Easy.
Absolutely. Sure. Seems like there's some samples.
Thanks. That's very interesting. Think about you can use urine to stabilize the soil, but with 30 kilometers per day, right?
Per day.
Per day.
Two
that's
lanes.
Right. Two lanes.
If it's 4 lanes, it would be 15.
Oh, okay. 2 lanes, right? Yeah. It's a fixed rate. You can't just drink water faster because then you die, right? With the ammonia, how long is the release period? Is it quite quick, like after it's released the ammonia? You can have ways to mitigate it, but is it like maybe 1 week, 2 weeks, or does it take years for it to dissipate out?
This is still research to be done, to be honest. I cannot fully comment on that, but I think we are looking at something in the order of weeks to months.
Yeah. So it's just the initial period.
Yes,
phase.
correct.
It's pretty much
Exactly.
Okay.
Absolutely.
Yeah, it just makes me think of what things you can do from a chemistry point of view to capture your local fix. If you're already looking at zeolites and some kind of acidic materials,
Sure.
which is the classic way to capture ammonia.
Absolutely.
Yeah, just a question around, I guess, the concentration of bicarbonates in urine, or carbonates in calcium is very, very low. So in terms of comparing that to lime, which is, 40, calcium carbonates about 70%. So you'd need a considerable amount, of liquid material in be working with to get the reaction that you want. So, yeah, the application of putting that amount of liquid into the system, I guess that's going to be a challenge for you.
Yes, what happens is that at the moment the lime or cement treatment we have is we don't add too much. It might be 5%, distribute it over a big area. And the current practice is that we don't even mix it with water, although we like to add some water because it makes it more homogeneous. But logistic wise, it's much easier to bring it in the truck. So in that sense, I guess this is really to be researched. I agree. This might be something we kind of conclude that it needs a lot of urine and concentration there. I agree. But I'm hoping that through this hub there are ways, to kind of maximize that. But yeah, I appreciate that. It's a very good point.
Thank you, Reza. Thank you very much.
Thank you.